This looks very complicated.
It is. But they're domos.
Gotcha, gotcha. Good afternoon, everyone. Thank you. Thank you for joining us. Good afternoon. Thank you for joining us for the 2017 Ig Informal Lectures at MIT. My name is John Jenkins. Once again, we're your proud host at the MIT Press Bookstore for the lectures. I would like to draw your attention to our book table outside and our new street address at 301 Mass Ave. Your support helps make events like this possible, and your patronage is, of course, appreciated. That's the end of my business, so I'm going to pass the mic to our MC, Mark, best in the biz, and he'll take the show from here. Thank you.
Thank you, John. Okay, thanks. Can everyone hear me? Yes. Okay. All right. I'm Mark Abrams. I'm the editor of the magazine called The Annals of Improbable Research. And in 1991, I and a bunch of people started this thing called the Ig Nobel Prize ceremony, which is why you're here today. This will be a series of short lectures by the new winners of the Ig Nobel Prizes. There are 10 prizes each year. 7 of the 10 new winners are with us. The others will be with us in the form of short video presents. And we also are very lucky to have 2 winners from past years who have come to join us from great distances. One of them has just wandered in, looking disheveled and yet handsome from Australia. This is John Culvenor, who will be our first speaker. And just stand there, try to look more disheveled. People remember that, yeah. And our final speaker is sitting over there, has come from England, although he is now working in Providence, Rhode Island, as a professor at the Rhode Island School of Design, Thomas Thwaites, who you may know as Goat Man. Thomas, want to take a quick bow? Each of the talks will be 5 minutes long. You will perhaps assist all of us in helping the speakers keep their speeches to 5 minutes. This will be our first speaker. This will be our final speaker. In between, we're going to go in the same order that we presented the prizes 2 nights ago, when the new Ig Nobel Prize winners were introduced to the public. That was in the ceremony at Harvard. Let's see. So Ig Nobel Prizes, just for the record, in case there's somebody here who doesn't know, Ig Nobel Prizes are awarded for achievements that make people laugh and then think. And that's it. You know, good, bad, important, trivial, who knows? None of those questions enters into it. It's just, have you done something that makes anyone, anywhere, laugh and then think? And there are about 10,000 new nominations in a typical year. So it's numerically quite an honor to be one of the chosen. Okay, I'm going to put on my ceremonial hat. This is a new hat, in case you're wondering. The old one wore out. It's a new one from eBay. And we're going to set up the timing mechanism here with our 3 partial timers. Please, if you came to the ceremony, you saw these 3 people. They are minor domos who are at the center of making the Ig Nobel ceremony work. We are going to try a slightly new variation on the timing scheme. And this is Susan Caney, who's also part of our mechanism, has been for quite a while, making everything work. We have 1 chair open. I'll explain what we're going to do, and then we need 1 more person, and I hope one of you will feel comfortable enough to volunteer to be that person. There are sounds that are related to things that one of the new winners did, and we fell in love with one of those sounds, and we're going to use that basic sound. Each winner has 5 minutes to talk. We're going to notify them every minute with the passage of each minute so they know where they are in time, and especially so they know if they've hit the limit, that they've hit the limit. Chris Dieter, who has a working time mechanism of some sort here, will be keeping track of when things start and how it goes. He will notify people down the line. They will be making cat sounds. progressively more complex as it reaches proximity to the living human speaker here. We have an open seat, as you can see here, for somebody who can make a cat sound that does not have to be and should not be very long or complex, but should be recognizable. Yes, if you could all please. If there's anyone who's enthusiastic, if you could wave your, just wave your arm if you're enthusiastic. What I suggest, seeing that we have 3 of these things, and that 2 of them are couples, is there any way we have access to a few more chairs? That this is an individual, so if you could come down here, please. And there's a couple here and a couple here who are doing some sort of battle. Not with each other, but internally. It might be kind of nice if you as a couple and you as a couple would also join us down here. And then the 5 of you could act as a single cat somehow. Would that be all right? Okay. By the way, we're live streaming this, and it's going to live forever on the internet. All right.
Good luck, man.
Yeah. All right. If you could do some sort of quick, enhanced n-dimensional rock, paper, scissors thing to decide who gets this chair, and then we will try to get more chairs. And then if you could really crowd together, that would...
Have one more chair.
Yeah, we'll have at least one more chair. We don't want to wear people out, so if we only have this one chair, if you could rotate with each speaker as to who gets the chair. And please crowd in here because it looks awkward and so is more entertaining for us to see. All right. Let's run through this just once so that we all know how this works, and so the speakers all understand. When a speaker begins talking, then Chris, you will note that.
Meow.
Okay, but you don't need to make a sound at the beginning. So each minute goes by. At the end of the first minute, you will make a sound as loud as you can and make sure the people next to you hear it, and it will be that single meow. So if we could try that at the end of 1 minute.
Meow.
And pass it down, please. So be meow, 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 meow. Okay?
Meow.
Wait. You 5 people are a single cat. Could we just rehearse you for a moment? So just one, da, 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 meow. One, let's try it again. Da, da, da.
Meow.
One more time.
Just project from right here.
Okay.
Yeah.
All right. So now the way it's going to work is cat, 5-part cat, 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 cat. Let's try it. So after this is from the beginning. So after 1 minute has passed.
Meow. Meow.
That's after the first minute. After another minute has passed.
Wait.
2 meows.
2 minutes. 2.
Meow, meow.
Okay. And try to make it rapid, because, be respectful of the speaker. After 3 minutes have passed.
Meow, meow, meow.
Okay. After 4 minutes have passed.
Meow, 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 meow.
Okay. And after 5 minutes, if they're still talking, start meowing and do not stop until the speaker does, okay? All of you. All right. Thank you. All right. It's going to be 5 minutes. This image you see up there, that's this year's Ig Nobel Prize. It's a physical prize. There's a new design every year. And that's what it looks like this year. Each of the winners who came to the ceremony, each of the teams got one of those. We're going to begin with a talk by, let me show you. This is not his slide, but it will illustrate it in a moment. John Culvenor. Let me read you the citation. I'll try to remember, and if I forget, remind me. I want to first read the citation, and then you get to see the person. So, John Culvenor, in 2003, was part of the team from Australia that won the Ig Nobel Physics Prize. They won for their published scientific report called An Analysis of the Forces Required to Drag Sheep Over Various Surfaces. An analysis of the forces required to drag sheep over various surfaces. It's got some nice diagrams in the paper, and we made this one up to illustrate on our own just because we thought it was fairly clear. I thought you might like to see this. All right. But rather than that quickie little thing, we have John Culvenor here himself. Please welcome John Culvenor.
Thanks.
From the moment he opens his mouth.
Thank you, Mark, and thank you, everyone. It's a great pleasure to be here, a real privilege. The sheep story is really about innovation and problem solving, and I'm an engineer. Most of my work is in design, accident analysis, problem solving, particularly creativity. New ideas are relatively easy to come by. They're not difficult to generate at all. But useful new ideas are, that's where the real challenge comes in. So I have a challenge for you that I didn't know I've had time for, so I'll set it for you now, and maybe you can solve it during the 5 minutes and the 5 minutes of questions afterwards. And if you can win the Newton's apple or the Vegemite. And the challenge is to imagine the apple rolling or the Vegemite on its side rolling, and take your piece of paper, at least there'll be now some use for this piece of paper that you've been given with the Ig Nobel information on it. Make a barrier. I'll wait for the meows to finish. They're done. Make a barrier out of that piece of paper that you can put on your little desk there and roll the apple or the Vegemite slowly at it, and that barrier will stop the object. There's your challenge. So on to barriers now, and something topical between the United States and Australia and other places. For us to think about. I know you want to build a wall. And if you're looking for a contractor, there's a good example. But don't forget Australia. We built a long barrier through Western Australia, 1,800 kilometres long. And there I am in that area of the world. And it's probably a better geographical example because it's hot and dry. There's a temperature, 47 Celsius, mightn't mean a lot to you in your lingo, but it's hot. Thank you, cats. Now, look, there's the barrier, and the other contractors may have made something more substantial. Fair enough. But there are different solutions for different problems. So the Aussie fence might be what you need. Now, the sheep, what can you learn from a sheep? The sheep need to be shorn every now and then, and that was the topic of our problem. There's one there, I kid you not. The gate was open when I found this sheep. And trying to take a shorter way, maybe a better way would have been to turn around. A lot of us probably suffer that problem. The work of sheep shear is a very physically demanding activity. That's the posture that they get into when doing the work. And the part of it we looked at was dragging the sheep. How do you make that easier? Do I get a deduction for the time used by the cats? Now, back to an American who was a professor at Harvard, Alice Hamilton. She appears on one of your stamps. And in public health, she was very influential, and is influential in a number of significant models in occupational health and safety nowadays. And her thesis, her argument was that if you want to solve health problems, you need to really act upstream. So it's about design interventions versus behavioural interventions. Trying to get away from things like signs and instructions at the behavioural end. That's the kind of intelligence we apply in Australia. That's from a roadside stop. where you can drink the water or not drink the water. It's really up to you. Or this one is on a welder. So signs and instructions are at the behavioural end. We want to act at the design end, and that's what the project was about. Putting science behind a creative idea. It might sound simple, drag the sheep downhill, but there is more to it than that, because the posture might change, the speed might change, the behaviour of the animal might change. And putting scientific measures around it really demonstrated that it was a practical idea. The little game people play with the 6 dots, you probably know the one, is about thinking outside the square. But really, what we actually need to do is think creatively inside the square. And it's the boundary is important, otherwise ideas won't be useful. You see, that's not helpful.
And we have time for each speaker. Because we have a lot of speakers, we have time for questions, but just a few. Just
that's the end of the talk, and the barrier you're making is
Katz?
that barrier.
Katz? Yeah. And now we're going to take, we'll have 2 questions. We have time for only 2. John, if you could come over toward here, you're a little more photogenic over here.
Okay.
I'll move around as much as you need to.
Because I'm further from the camera?
Yeah, something like that. And we have a couple of microphones here that will go to you when you ask a question. So if you could wait till the microphone gets to you. Is there somebody here who could help maybe one of the cats wrangle the microphones? One of them? We have one over here? Oh, you're all set? Oh, we're all set. We're all set. Okay, I'm sorry. Thank you for, this is a very, very cooperative and wonderful cat. Thank you. Okay. If you have a question, raise your arm and just wave it wildly so we can notice you and so everybody else can admire you. All right. So, first question over here.
So you're talking about the dragging of the sheep. Does it make a difference when you drag the sheep downhill if it's an African sheep or a European sheep?
Aussie sheep are probably Spanish sheep, so that's pretty close to Africa. I guess they're on the border.
Let me ask the questioner, do you have reason to believe that it makes a difference?
Okay.
Do you have any comment on that?
I really don't get it.
Okay. And I tell you, we'll make it 3 questions per. So the second question will be right here.
Has anyone solved the problem? Up there, okay.
Okay, but the question would be right here.
Yeah.
If you could ask your question.
It's well known among hunters that if you drag a deer head first, it's easier than dragging it feet first because of the way the fur points. Is that true of a sheep as well?
Some parts of it would be true, in that if you control the head of the sheep, you control the whole animal. But the wool itself doesn't have that kind of texture. No.
It also helps that the deer hunters drag are usually dead.
Right. Yeah.
Okay, and there's a question. Somebody raise an arm. Okay, see an arm raised right there. Well, wait until the world can hear you because there's a microphone right in front of you. Yes, thank you.
And what position you drag the sheep in? As in sideways, head first?
They're always dragged
Backwards?
pretty well the same way by the front legs, but individuals will have their own, I suppose, posture and style, and that's one of the reasons to test real people doing this job as real as possible, because the actual person is going to do it differently from a model.
But there may be the most efficient position to drag a sheep in.
Well, there may be better ways, but you can probably rely to some degree on human beings finding out over the years the best way to do something within the environment that they're in.
Okay, and that's our 3 questions. I'm sorry we don't have time for more, but the winners will all stick around later if you want to talk to them, if you have personal questions or problems that need to be solved. Thank you, John Culvenor. Our next speaker is the winner of this year's Ig Nobel Physics Prize. He joins us from France. He used to be here at MIT. The prize is awarded to Marcantoine Fardan for using fluid dynamics to probe the question, can a cat be both a solid and a liquid? Here he is. Oh, okay. Okay, and we want to do what page? Single page continuous to what? What do you want?
I think it's like a slideshow thing. Full screen mode, or maybe full screen.
Okay.
Yeah.
Okay.
Thanks.
Great. And if you could speak into the microphone here.
All right. So yeah, I'm happy to be here and to talk a little bit about rheology. So rheology is the study of flow. The root is rheo, to flow. And you can find also the root in rhythm. And really, like, what it's telling you is that rheology, in some sense, has to do with time. And what you can see, what you can observe, the state of what you can observe, may depend on time and comparison of time scales. Rheology doesn't really specializes in a particular state of matter or a particular system. It rather try to find systems that don't quite fit in the usual categories. So the system I'm going to be talking about today is known by all. And it's cats. So why cats? Cats are quite popular on the internet, and I spend quite some time on the internet. I was on this, thank you, cats. I went on this blog called Bored Panda, and they were asking the question, are cats liquid? So the question was based on the common definition that a liquid is a material that can adapt its shape to a container. And so it's in contrast with a gas that can adapt both its shape and volume to the container, and a solid that won't adapt neither shape nor volume. So I couldn't refrain from using this question to talk about some actual problems that are being studied in rheology. So I dressed up the question in scientific terms, and that was the beginning of the paper. So are cats liquid? So based on the definition and some experimental evidence, it seems to be the case. But so the question really should help us realize that behind those traditional definition of the states of matter, they are verbs basically. So to adapt one shape or volume is an action, and it should be unfolding in time with a characteristic time. So in rheology, this time is usually called the relaxation time, and that's not like a joke. It's true. And so I use the letter tau here to represent this time because, you know, since it's a Greek letter, it's going to look scientific. And so really the question is not whether a material is going to be liquid or solid or gas. The question is more like, what is its relaxation time? So in rheology, one of the most important questions usually at the beginning of a study is, what is the relaxation time? What does it depend on? And so for cat, that's a good question. The relaxation time could depend on the container itself, and that could be a complication. So the time the cat needs to adapt its shape might depend on the substrate. That's something that is actually studied in rheology. So if we assume that the relaxation time is known, then like determining the state of the material depends on the comparison between this relaxation time and another time scale that is called the experimental time scale or something like that. And it's usually just the duration of the experiment. So by comparing the two times can be done by computing their ratio. So that's this number here that is called the Deborah number. And if the Deborah number is smaller than 1, it means that the material behaves mostly as a fluid. And if it is larger than 1, it behaves mostly as a solid. And so even if the relaxation time is very big, the material can nonetheless flow if you're waiting long enough. And it's usually illustrated by this experiment that has been running since the 1930s, where tar is pouring out of a funnel, but 9 drops have fallen only since almost 100 years. I think this was awarded the 2005 Ig Nobel Prize. So cats seem to be able to behave, to show properties of all 3 states. They can bounce around and behave like elastic solids. They can fill the container and behave as a liquid. And they can also sometimes change their volume, especially if they are confronted to a stressful situation. So the Deborah number introduces 2 out of the most important time scales. And in the paper, I also talk about another one, and you can read all of this online on the paper. Thank you, Katz.
Thank you, Mark. We have time for 3 questions. So same. All right, that's not a question for him. The question, in case you didn't hear, was, can we put the timers in a jar? No, unless you have a proper size jar. Raise your arm, wave it a lot so that one of our microphone people can find you, and then wait till the microphone gets to you. John, your choice. Okay. And the next question will be your choice, the next person.
So, can you expand this theory to model a multi-cat state instead of just a single cat environment?
Yeah, well, I didn't put it on the presentation, but I've seen, those are not my data. But I saw this picture of multiple boxes, and they start to be empty boxes, and cats are wandering around, and as time goes by, they start filling in and like crowding inside the boxes. So like I think there is some collective behavior that are possible.
Okay. Next question from over here somewhere. Is there some arm waving? Arm waving, that's what it's all about. Yes.
Thank you. What about better animals like dogs?
So,
now let's be polite, people.
So I don't know about dogs, but I mean there are some preliminary data on other types of felines. So like there are some stuff on tigers and even on fox. So that could open like a road for investigation on the behavior of dogs and their state of matter.
Okay. Next question. Final question. Raise your arm.
Do you think the difference between cats and liquids might come down to motivation to conform to the shape?
Well, yeah, I think it comes down to complexity in the sense that like a liquid usually has like one relaxation time and it's not like too hard to figure out what it is. For a cat, like the things on which it might depend are harder to pinpoint, I think.
I have a question for the person who asked a question. Your question seems to imply that you think that this would be true of human beings, that it's a matter of motivation, whether you're a solid or a liquid. Is this true of you? Could you please wait until this event is finished? All right. Was that 3 questions now?
I think it was.
Yeah, great. Thank you, Mark. Our next speakers, it's the team that won this year's Ig Nobel Peace Prize. Between them, they represent Switzerland, Canada, the Netherlands, and the USA. Most of them have come from Switzerland to join us. The award went to Milo Puhan, Alex Suarez, Christian Locasio, Alfred Zahn, Marcus Heitz, and Otto Braindley for demonstrating that regular playing of a didgeridoo is an effective treatment for obstructive sleep apnea and snoring. Please welcome the Ig Nobel Peace Prize winners. Let's see. Now, is this yours or that Mark's? That's Mark's. This one?
The YouTube. Yes, exactly.
Okay. And should I start it up?
Yeah, yeah.
Okay. And maximize.
The peaceful suburbs of Zurich, Switzerland. Or are they? Sadly not, you see. Hidden deep beneath the snow-capped roofs, there lurks the sound
Can we have
of
the lights
snoring.
down?
A sound so bad, it's driving some people to want to kill. 10. But now there is potential relief for the long-suffering citizens of Zurich's snoring zone. No, Tibetan Buddhism has not put down new roots in the Alps. These frozen gnomes of Zurich are undertaking the latest low-tech cure to nighttime rumbles. Prescribed by this man, Dr. Milo Puhan, his team at the local hospital. The play of the didgeridoo.
Well, with the didgeridoo, we try to exercise the muscles of the upper airways, and thereby the collapsibility of the airways is reduced, so we don't snore anymore and you have less sleep apneas.
Snoring occurs when the muscles at the back of the throat relax and collapse in on one another, causing them to vibrate as we breathe in and out. In most cases, it simply causes a vibration and that annoying noise. But in some cases, the muscles get stuck together, blocking the airways and effectively stopping the patient from breathing. It's called sleep apnea. And at the very least, it leads to the patient constantly waking up. But in the worst cases, it results in high blood pressure and heart disease. But what is it about playing the didgeridoo that's so beneficial? Why not the bagpipes or the trombone? Well, in part, it's the sound of the didgeridoo. It seems that the low-frequency sound gives the throat the perfect massage. Dr. Puhan's assistant, Dr. Braindley, will demonstrate to those of you who are not squeamish.
With the bronchoscope passing through the nose, I can show you where the snoring happens and the apnea is. Further down in the nose, you will see a valve which closes the nose through the mouth, and where by vibration you have the snoring sound, and by complete closure you have the apneas.
And now a television first. Didgeridoo playing as never seen before. From the inside. And you can immediately see what a workout the low frequency of the didgeridoo gives the throat. In addition to the good vibrations of the didgeridoo, is the technique of circular breathing it requires. To keep the note continuous, players have to breathe in through the nose at the same time as breathing out through the mouth. And that strengthens exactly the muscles that collapse during snoring and sleep apnea.
At first I had 17 sleep apneas per hour in the night, and
All right, so we're going to stop the video here.
Can we have the lights back up, please? Before they say anything, is there anyone here who would like to volunteer to come up here and have us stick a tube down your nose? Oh, how unfortunate. Well, we'll just have to listen to this without having a live demonstration of that. Ladies and gentlemen, the Peace Prize winners.
Yeah, thank you. We thought we have to show this video. It's so more informative than if we are talking here for 5 minutes. So it basically shows also why we did the study. So there was the observation made by Alex Suarez, who actually suffered from obstructive sleep apnea syndrome, and made that experience that playing the didgeridoo helps. And then before we started this study, we went into literature and if there is similar ideas around, and indeed there were. I mean, the discussion that you can actively influence some of the structure of the upper airways have been around for a number of years. So there's the muscles, soft tissue, fat pads, and so on. And so this is why there is actually a rationale for doing that. And so we embarked on that small randomized trial where some participants with obstructive sleep apnea played for 4 months and the others didn't. And we found this quite substantial reduction in obstructive sleep apneas and daytime sleepiness and snoring. Yeah, and then we had many wonderful experiences. You see, yeah, we won't take the 5 minutes because of so we made many wonderful experiences after we published this, and this was one of them. So this guy you saw first, Sid Goldberg, is a director from Canada, and then he called us. I want to do a little movie for the National Geographic, and he told us, but can we see if somebody plays? Can we see from inside when somebody plays the didgeridoo? So that was his idea, and then we were thinking, how can we make that possible? And it was possible actually because Alex is such a master of playing the didgeridoo that he did tolerate this endoscope that was put into his nose. But for us it was very interesting to see the vibrations and all that working out of the upper airways. Yeah, since then I think that's the story. So we are very happy to be here 11 years after we have actually published that study for the first time.
Yeah. Would you like to say something, please?
Okay, I will play some sound. Yes, not this sound. And I will show you a little bit outside of the throat how I'm using muscles, because I don't want to have it inside again. Yeah.
Very nice, but if there's a doctor here, could somebody go and check on the poor man in the sound booth? You okay? Good. Okay. It's fine. Okay. Anything else you'd like to say?
No, I think we
Okay, great.
take questions.
Great. Thank you very much. And so now we'll take some questions. Do you have a question? Wait until we get to the microphone. Or if you have a question, why don't you, in fact, come around, cat-like, to the microphone here. Please, yes.
So my question is, since you're from Switzerland, would an Alphorn do too?
What? Would an Alphorn do the same? You know this very long wooden...
The Swiss Alphorn, I was trying that, yes, because I'm from Switzerland. And the problem is with all the classical instruments is that they are producing a very clear sound. And I was trying it, and the problem is that it doesn't make an effect in vibration sense deeper of the throat, back of the tongue. And this was the reason to me to go to the didgeridoo, because the vibrations are much more higher that you saw in the film. And yeah, so it doesn't work.
Yeah, nice question. A couple more questions? We're here.
Have you studied if other conditions can be cured by this kind of musical instrument or other different instruments?
Have you studied some other medical conditions using this same kind of treatment? Do you have specific medical conditions in mind? And I don't want to embarrass you, but is it anything personal?
Not me personally, but I'm just thinking about other respiratory conditions.
Other respiratory conditions.
Actually, we haven't, but a number of groups around the world contacted Alex, and I think he's working with a group at Stanford at the moment to set up studies for which disorders? Which diseases?
Yes, it's also
Sleep apnea?
Sleep apnea. But I have treated 2,500 people by myself the last years. And I had a lot of people with asthma, perhaps, or this experience was of asthma or respiration tract disorders. This is helping about vibrations and strengthen the muscles.
And final question, will the gentleman in the middle there popped up before anybody else. All right, well, because I just did this, we'll make it 4 questions. Okay, so here first and there.
So are you concerned about having a lack of like a controlled didgeridoo? So like a non-didgeridoo?
That's a very good question. You know, we actually use this study, and others use that a lot for teaching purposes, you know, in clinical trials and so on. And this is one of the tricky questions. We didn't come up with a control intervention because we couldn't exclude from other wind instruments that they are effective. We didn't have no idea to come up with a placebo didgeridoo kind of stuff. But what we did, we promised everybody to play and learn the didgeridoo. So the thing what we did, we just randomized them to starting immediately or waiting for 4 months. So this is what a way to deal with the expectations. But it's a good question, because for this kind of treatment, it's always very hard to find kind of a control intervention.
Okay, and a question up here. Yeah, you in the dark. Yeah. Yes.
Is there a way to use this instrument to actually help the people from the first talk to get the sheep all the way up?
Well, I think I have some experience with animals also. Perhaps, you know these dogs with a lot of skin here. And we tried to play with them, but not by themselves. We are playing vibrations to them. So I see there a bridge.
Okay, thank you very much. The Peace Prize winner. The Economics Prize winners have come here from Australia on a separate plane from the man who dragged sheep for scientific purposes. This year's Economics Prize was awarded to Matthew Rockloff and Nancy Greer for their experiments to see how contact with a live crocodile affects a person's willingness to gamble. Here are the Economics Prize winners.
G'day.
I'd like to say I feel very at home with the Vegemite and the didgeridoo.
Yeah. Okay, so this is, of course, a tale of how crocodiles make you want to or not want to gamble. But it isn't. The crocodile is actually just a bit of a prop that we used, and I'll explain that as we go through. So there's an issue here. Gambling causes one to be excited. That's what is fun about gambling. That's why people use it as an entertainment product. It's fun, it jazzes you up, and that's the feeling that you get from it. But what we were really interested in is, once you're excited by gambling, does that cause you, in some circumstances, to gamble imprudently, to make poor gambling decisions? That is, based on your physiological arousal, does your gambling get bad? And this is actually very hard to study, because the thing is, it's all bound together. When you gamble, you get excited. When you get excited, that may cause you to gamble imprudently, but you're already gambling, and so how do you separate those out? Thank you, Katz. And so, in essence, what we needed to do is create excitement before people gamble.
Yes, so what Matt had me do is go out to a crocodile farm in Queensland, Australia, where tourists come into the farm, and it's a tour, so they show them all the crocodiles, and at the end of the tour, they get to hold a crocodile. So we had two groups. One experimental group were those who came into the tour, and so they participated before the tour. And the other group, the crocodile conditioned group, were the ones who had held the crocodile. And this is the crocodile in question, or one of them. It's about a metre long, 5 years old juvenile crocodile, and its mouth is taped shut, and it's got sharp protruding teeth on the outside. So this is supposed to make them more excited than the other group who hadn't even seen any crocodiles or held a crocodile. And I held that crocodile. And as we measured them, because when we did the experiment, we measured their skin conductance, so how excited they were at baseline. And at baseline, before they gambled, you can see the croc people much more excited than the other group. Right? Then we got them to gamble. And we measured their positive and negative effect. And this is where Matt will come in for the data analysis and findings.
Thank you. Okay, so this is the main result that we found. Obviously, there's more detail here, but we found for people who with one or more pre-existing gambling problems, if they didn't have a negative emotional state, that is, if they generally felt positive at the moment that they were participating in this experiment, when they held the crocodile, indeed, they gambled with much higher bet sizes, substantially higher bet sizes than, and that's that blue line there, than when they didn't hold the crocodile. The exact opposite happened for people who were, thank you, Katz, who are in a low negative, or had negative emotions. That is, they gambled a lot without the crocodile, but with the crocodile, after holding the crocodile, that is, they gambled very small bet sizes. So how does emotion affect your gambling? Well, it depends on what your interpretation of the emotion is. So here it is. That is, when you have the stimulus material, which is the crocodile, and you label that, this is based on the two-factor theory of emotion, Schachter and Singer, you label that as a negative emotion, you actually walk away with more money. Okay, so if your emotional feelings from gambling are negative, they cause you to quit early and walk away, or in this case, gamble lower bet sizes, which will make you lose less money. If, however, on the top side, you label it as a positive emotion, that is, your feelings are feelings of excitement, maybe feelings of luck, then, you walk away with very little money. So that's the result, and that's all we have. Thank you very much. On time.
Questions? So if you have a question, raise your arm vigorously. That's being wonderfully vigorous back there. Oh, that microphone doesn't seem to be on.
Did you consider trying to drag the alligator, crocodile?
Did I consider trying to
drag the crocodile, or drag the person, and drag the person toward the crocodile, or?
They willingly held it. I'm pretty sure the farm wouldn't want them to drag it across the farm.
Yeah, I think an important thing to remember is it's not about how crocodiles affect gambling. It's actually how emotions affect gambling. The crocodile was just a convenient way of creating emotions that people weren't aware of why they were excited. It was, relatively mild manipulation. They translated that to the gambling experience, and presumably when you gamble for real in a casino, then if you get carried away emotionally, it could be negative emotions, could be positive emotions. If it's positive emotions, it may cause you to gamble more than you otherwise would want to. People think that their gambling is under their conscious control. I decide how much I bet. I decide when to quit. But in fact, what we've shown was that emotions actually affect your decisions, and sometimes they're emotions you're not aware of. And in fact, in interviews afterwards, we found that nobody mentioned the croc or any situation around it, or even their emotions about how much they bet or why they quit. It was always a cognitive explanation, not an emotional explanation, but emotions actually do very much drive people's gambling decisions.
Have either of you had any inquiries from casino owners asking you for advice on how many crocodiles to buy and where to position them?
Well, there is. I'm glad you asked because we
there's
haven't
a new
had
casino being built about 2 miles from here.
Yes. Yeah. Well, there
We
is.
don't want to encourage that.
Yeah, we do not. No. Don't encourage crocodiles in casinos. It turns out that when we first presented this research, it was at a casino, the Cairns Casino, where they just happened to have Goliath, which is a very, very large saltwater crocodile in the center of the casino.
Just happened to have.
Just happened to have. That's right. Yeah. I mean, that's what they want us to believe, right? But,
yeah.
Is he still
I
there?
don't think you knew about that.
I don't know. He's probably dead by now. He's probably hen big by now. I'm not sure, but that was 10 years ago. Again, this is a bit of an old study. So.
Okay. You were going to say. Okay. Next question. There's a vigorous raiser here and a vigorous raiser there. So here first and then there. Here and then there. Or there and then here. Okay.
So I was wondering if the images on the dials of the slot machines maybe like contained, like reptiles, or was it just fruit?
Yeah, the images on the slot machine were fruit. It turns out that that's the most common things. In fact, in the UK, slot machines are called fruit machines. But it is interesting because the dials of the fruit as they spin, it's like fruit falling from the sky. And so I think there may be some implicit idea of how these fruit machines or slot machines are produced, that they actually trigger us in some kind of primordial way. It's like free food falling from the sky. I'm not kidding. I think this is really, really why those symbols. So there's a lot of things in slot machine design that have to do with symbols that are often ancient Egypt, sort of things that harken back to magical beliefs and the past, and things that come for free, and the direction of falling down, into this sort of lucky tray at the bottom.
Matt, that fruit mention is interesting. So,
yep.
if you were to have gamblers hold fruit in their hand before they gamble, does that affect how much they gamble?
Well, that could be another Ig Nobel Prize.
You can hold the
And
fruit
much
too.
easier to do than a crocodile farm.
Okay, now we had another question here.
Yes. Is it possible, or did you consider that the control group may already have had a heightened arousal because they knew they were about to go on a tour of a crocodile farm?
Well, I was there. So literally before the tour, you had about half an hour before it started, and you weren't actually allowed to go near any of the crocodiles beforehand. So they literally walked in the door, and I'd randomly pick either control or experiment, and they did it straight away. So I don't think they would have been excited, and the measurement shows that baseline they weren't. So.
Okay, thank you very much. The Economics Prize winners. Nicole, I skipped over you, didn't I? I skipped over you before? You were going to do the didgeridoo? Yeah. Something I skipped over before, and I apologize, was we're lucky enough to have here with us Nicole Sharp, who some of you know quite well from her website, FYFD, which is the biggest fluid dynamics website in the universe, probably. Not just on Earth. And
as far as we know.
Nicole has been looking into the question of fluid dynamics and didgeridoo playing, and has been consulting with the didgeridoo experts here. and is going to give us a little 2-minute talk about fluid dynamics and didgeridoos and throats. Nicole Sharp. And what's the name of your website?
So I'm Nicole Sharp. I run FYFD. As he said, it's a fluid dynamics blog. So I'm going to do that thing that physicists do where they say that they know how everything works, even in fields that they know nothing about. So I'm going to tell you about how snoring works. And for this, I have a lovely demo that you can reproduce at home. Namely, I have a plastic cup right here, which I have put a hole into the bottom of. And I have a slip of paper right here, just normal paper. Nothing weird about that, right? All right. So the back of your throat you saw before, you have this area where the sinuses and the esophagus are kind of coming together, and you have what's called the soft palate there. In engineering, we would refer to it as a cantilevered beam because it's held at one end and free at the other. So it's going to look something like this whenever you're sleeping and snoring. You can hopefully see there that it's flapping back and forth and it whacks one end and kind of gets stuck there. That's your sleep apnea, that's the snoring, whenever you're getting constriction on one side. The reason this happens fluid dynamically is because of an interaction between the structural mechanics of your soft palate and the flow going over it. So you may have heard of this guy Bernoulli, who talked about how if you have a constriction and air is moving faster in one spot, then you have a lower pressure. And that, in this case, when you have something floppy, like a really soft palate, is going to tend to pull it to one side and close it. So you practice playing your didgeridoo, you end up stiffening the muscles around there. So this is another slip of paper, same size, but now it's 3 times as thick, so it's much stiffer than before. I get a little bit of flutter there, but no snoring.
Thank you. Yeah, okay. And we'll take maybe one question. Gary, do you happen to have a question? No. Wow!
Perfect explanation.
This is Gary Dreyfus, who has worked and done research here at MIT in various ways for decades. This is a historic moment. This is the first time Gary Dreyfus has been in a room with people talking about something interesting, and he has not had a question. Could we? Is there somebody who does have a question? We have time for one question. And do we have, why don't you come right up here? Yeah.
So the question I have is, what practical importance does this have? Can we make our palates thicker in some way to help?
So there are actually surgeries where people will insert stuff into the soft palate, but my understanding is you can learn to play the didgeridoo.
Nicole Sharp. Okay, and the website is FYFD. It's a Tumblr. Where are we? The Anatomy Prize. This year's Ig Nobel Anatomy Prize was awarded to Dr. James Heathcote, who has joined us today from England. Dr. Heathcote won the Anatomy Prize for his medical research study called "Why Do Old Men Have Big Ears?" Please welcome Dr. James Heathcote.
Thank you, Mark. Thank you, everybody. So let me look down. Yeah. So I'm James Heathcote. I'm a general practitioner, family physician in London, southeast London. And the smiley face was meant to remind me to say how delighted I am to be here, and I forgot. So, doesn't appear on your slide. How exciting. Okay. So that's because it's on this one. In 1995, I was lucky enough to have a paper published in the British Medical Journal entitled "Why Do Old Men Have Big Ears?" And the origin of this interesting question it began here at a place called Boar Place in Kent, just outside London, where the provost of our local faculty of the Royal College of General Practitioners convened a group to talk about research and how we might do some research in general practice. And after a supper, a very good supper, we were throwing around ideas. And somebody, I think it was me, said, I didn't say that. I said, why do old men have big ears? And the room divided. Half of you said, yes, they do. And the other half said, no, they don't. It's just that they wear their hair long, or that you notice the men with really big ears. But when you look at this chap here, you cannot imagine those ears on a younger man. The bus is there because that's a good place to go and see old men. So if you're still a little bit skeptical, this is Har Gobind Khurana, who was an Indian-American biochemist, a late man. But if you look, I think you would agree his ears got bigger. This is another Nobel laureate. This is Nadine Gordimer, a South African writer. So it's men and women. Mother Teresa, you'll note, covered her ears. And why? Why did Einstein grow his hair so long? So what we did, this was very high-tech stuff. We went out, we bought a 6-inch ruler and a piece of paper, and we borrowed a biro. And we measured the ears from top to bottom, simply the length of 206 patients. And this is what we found. And if you're at all scientific, you can see, we measured from age 30. At the bottom, 30-year-olds generally have small ears. Bad graph, it doesn't go down to 0, but this was 1997. And as they get older, the ear length, you see more longer ears at older age groups. This was the clever bit. You can read it by going online. But basically, it says that your ears grow by about 2.2 millimeters a decade. So what have I learnt? I've learnt that scientists love measuring ears. Here we go. Whole lot of trials from Texas, Tokyo, Turkey, Providence, Korea, from Berlin, Madhya Pradesh. Indians have big ears, Afro-Caribbeans have small ears. Leiden, Milan, London, Naples. And if you look at the Leiden one, the cross-sectional anthropometric study of the external ear, that's what we should have called my study. But why do old men have good ears is sexy. If you want to get published, have a sexy title. Don't make it too complicated. Keep checking your numbers. 12 years after the study was published, a chap called Frank Wilk, who's an accountant somewhere in the world, wrote to the BMJ and said, did you know that the paper originally said that the average ear length was 650 millimeters? It's that big. And I missed it, and the proofreaders missed it. Andy Warhol was right. This is my second moment of fame. The first was when this was published. And then there was somebody who probably did it first, but he did it in 1997. So this was before the internet, before computerization, before this great explosion of knowledge. So, did it make people laugh and then they think, well, it's made you laugh, it made lots of people laugh. And can we explain it? Have we answered it? Well, of course the answer is no, that would be very dull. Thank you to Mark, Stephanie, college people, BMJ people, Sandra and David, Ian, David, Karen, who helped with the research, to my hosts here. And I'll end with a picture. This is from 1913, minor German artist called Eduard von Gebhardt. But look at his old man. Thank you.
Wave your arm. The first waving arm I've seen is here. Wow, we have lots of waving arms. Let's take this one first, right up to the microphone.
Thank you. Were you able to rule out the possibility that people with shorter ears die sooner and therefore are less represented?
No. I want to point out, well, I already have this microphone. I want to point out that standing here, looking over at all of you in the audience, and having seen all the responses of who wants to ask questions for which topic, the other questions, it was a pretty even mix of men and women. This, it's dominated by men who want. And one of them is right here, Gary Dreyfus. Gary, wait until the microphone shows up. What?
Not a question, but an observation. I think I have a freely available source of really good longitudinal data for you.
Right.
The movies 7 Up, 14 Up, 21 Up, et cetera,
All
et
right.
cetera. It's the same subjects over and over again every 7 years. What are they up to now? It's quite a bit. And I think with modern computer techniques, you could probably get everybody's ear lengths.
Thank you. One of those subsequent papers actually did that. They looked at photographs that had been taken, and they did it from the photographs. But it's intriguing to me just how many people have actually basically done the same research again, but they've sort of done it because they're ENT surgeons or plastic surgeons or forensic pathologists, and they've tried to make it more complicated, make it difficult, but people just can't resist measuring ears. It's great fun. I commend it to you. Do it yourself. Yeah.
Okay, we have two there. Because you're waving almost in synchrony, we're going to take both of you. First, the younger man with the little ears.
My question is this on? Did you test for whether deafness has any effect on growth of ears over time?
Excuse me, the first thing you're supposed to say is what?
So I meant to say, yes, you're right. When we do insurance medicals, then we have to ask, for driving medicals, we have to ask, do you have any problem with your hearing? And patients usually don't spot it, but every now and again somebody goes, what? And I'm always so pleased. So you asked. Yeah, I suppose the only problem is we actually ruled out anyone who had a serious hearing problem because we asked their consent first.
And now the question from the gentleman behind him who has 2 ears, I notice. Yeah.
I was going to ask more or less the same question, but I think it would be a great subject for a research proposal. Maybe an institute.
Right. I'll say what. Thank you.
Okay. Thank you. Dr. Heathcote.
Thank you very much.
The Ig Nobel Biology Prize was awarded to a team from Japan, Brazil, and Switzerland. The team is Yasunori Yoshizawa, Rodrigo Ferreira, Yoshitaka Kamimura, and Charles Lienhard. They were honored for their discovery of a female penis and a male vagina in a cave insect. That's it. They were not able to travel to be with us because they had already scheduled an expedition to be out in the field doing research now. But they offered to, in advance of that, prepare an acceptance speech, film an acceptance speech of them inside a cave. It's brief, and I'll show you now. If you came to the ceremony the other day, you got to see this also.
It's a great honor to receive the Ig Nobel Prize.
We're now exploring some caves this time in Japan. Unfortunately, could not attend the ceremony.
In the study, we reported a sex reverse cave insects in which females have a penis.
Yes, I peeped their sex life every 30 minutes and found out the females anchor the males by using her spiny penis up to 70 hours.
Every dictionaries around the world express penis as a male structure. Our discovery made billions of dictionaries outdated.
Yeah. So let's explore for other improbable insects. Thank you very much.
Thank you. Thank you.
And some of you, if we're lucky, maybe their travel schedule will allow them to come and be here and answer questions that you may have about this. The Fluid Dynamics Prize this year was awarded to Ji-won Han for studying and he is from South Korea and also now from the US. He was in high school in South Korea when he wrote this paper. He's now a student at the University of Virginia. He was honored for studying the dynamics of liquid sloshing to learn what happens when a person walks backwards while carrying a cup of coffee. Ji-won Han.
Wait, so is this the front?
Yeah.
I got you. All right, so I prepared way too much material, but at the end of the day, I'm going to be talking about two things: why we spill coffee and how not to spill coffee. So listen up. All right, so here's a video of me spilling coffee in a very slow manner. So we're going to talk about three things. We're going to talk about what resonance is, what resonance has to do with anything, especially coffee spillage, excuse me, and how do we stop that? So, what is resonance? So resonance happens when there are two oscillating entities. In this case, we have the coffee and we have the coffee cup. Now, the coffee is going to slosh around at its own frequency, but so would the coffee cup, because we're walking, and walking is periodic, it's oscillation. And when those two frequencies are the same, we start to cry. Now, that is called resonance. And again, I have a video of resonance. It looks nasty, doesn't it? So back to science. How can you figure out the liquid oscillation? So what I did was I took a camera, meow, and I filmed it. And then I tracked one point on the surface, put it on a graph, and then took its frequency components. Now, all that means is, you don't need to freak out, all that means is there's a definitive frequency at 4 hertz, right beneath 4 hertz, so around 3.9 hertz, that the liquid oscillates at. Now, as physicists, we can also calculate this using math, and more math. Now, they're all off because this is a Mac. But we get the conclusion that it should be around 3.9 hertz, so hooray, math works. Now, the next part, how do we measure the oscillation of the cup? Now, we do that using our beloved phones, and by attaching them to our cups. Now, just for definition, let's say that the walking distance is the y-axis. And then sideways would be x, up would be z, and then forward would be y. What we do is we stick a phone on the cup and then measure the acceleration, because our phones are fantastic accelerometers. And using that, here's the data. And now again, we see the frequency spectrum of this data, and we can see that there's a peak right beneath 4 hertz. That was exactly how the liquid oscillated. We have two entities oscillating at the same frequency, and hence resonance. And that's why we spill coffee. Now, how to spill less? There are 4 suggestions that I can make. First, walk backwards. Second, hold it from the top. Third and fourth, use a lot of foam, or you can use a cell-divided cup, which I will show you. Now, first, why do we walk backwards? So we do the same experiment for walking forwards, but we walk backwards instead. And we can see that there is actually no significant frequency when we walk backwards. This is because, unless you're from a certain culture, we used to walk in front. And if we walk backwards, since we are not used to it, we make irregular steps, and hence we are not oscillating at the same frequency. That displaces the resonance. And meow. Now, what's the claw hand posture? It's holding the cup from the top like that. And what that does is, if we hold the cup like this, we only have 1 degree of freedom of motion. If we hold the cup like that, we have 1 degree and then another using our fingers. And that changes the property of the oscillations. And it changes it drastically by decreasing the frequency components at the resonant frequency. Hurrah! It also has another effect, which is it decreases the amount of force applied on the cup. As you can see, the red lines are a lot smaller. That's all that means. So adding foam, those of you who like cappuccino, well, you're in good luck, because if you have foam, you're less likely to spill coffee a lot more. And then, now, for those of you inclined to drink from a cup that looks a bit unconventional, and a lot harder to carry around and show around your friends and also clean. And finally, the most exciting part about my research to me was the physics part. And as we all do, I created a model, a theoretical model that would embody these properties of the single hand, the normal hand posture, and the claw hand posture. And guess what? Physics works. We see a strong trend at the 4 hertz, just as we predicted or saw in the data. And for the claw hand model, we see no frequency at 4 hertz. Thank you. So now, I would like to end this speech with a conclusion and a message. So first, the normal hand posture will likely spill. However, the claw hand method definitely works. Walking backwards, maybe not. But all in all, thanks for loving science, but I suggest that you get yourself lid.
We will take some questions. Before that, though, could I persuade you to give us some sort of demonstration?
Would you mind if I borrowed your coffee?
Yeah.
Should I remove the lid first?
Okay. And do you want to get an assistant from the audience to help you, or do it yourself?
I would like one assistant, please.
You
Anyone?
choose.
Hands up, hands up. Oh, he's already here. All right. All right, this is going to be really, really hard. Do you mind if I actually borrow all your coffee? Can you pour this in here?
Okay, face the audience.
Go back now, thanks. Right, so this is walking in front. Switch hands.
Switch hands. So you can see.
Good thing I have a long cup.
That was wonderful. Before we take questions, I happen to notice that here in this room with us is one of the great demonstrators who has ever worked at MIT. And I'm glad I happen to be glancing in this direction. His name is Gary Dreyfus. I wonder if you might be willing to do a quick demonstration of this?
I'm not sure if big ears have anything to do with this, but
So, backwards with a claw grip, is that the idea?
that's the safest way to do it.
Gary Dreyfus. Okay, now we'll take some questions. 3 questions. Okay, your choice, whoever.
My choice.
Your choice.
Oh boy. He's been holding his hands for like the entire time, so.
So I'm a cat slave basically, and my cats like to sleep in boxes. And since we've established like cats, are kind of liquidy, and I have to sometimes I carry them around in their boxes, and the way they're sleeping in the boxes. Would you recommend any techniques for maybe holding the boxes in which the cats sleep, so that they don't slosh around and wake up and get mad at me and make my life hell?
I would recommend that you put a lot of foam on top of it. But seriously speaking though, I know this for unknown reasons, but it's best to hold a cat from its neck and grab it by the claw hand grip. It makes it feel at home, as if it's like mother is biting onto its neck, which is supposed to be comfortable. Not my mom, but.
And have you noticed, if I can ask you a further question about your cats, have you noticed that your cats have any problem with snoring? Oh, if they do, we have some people here who...
Cat remedyists.
Yeah, let's take the next question.
Can I just go all over there? Is that Dan? Are you Dan? No. I'm sorry.
So, hello? Yeah. So, do you think that Michael Jackson came up with this moonwalking because he wanted to avoid coffee spilling?
This calls for demonstration. Unfortunately, I've never seen him drinking coffee, but you know, being a half Michael Jackson myself. I'm not, guys. This is going to be terrible.
Thank you. Okay, one more question.
No questions.
If you're raising your arm, yeah.
That is a great question. But with greater cups comes greater coffee. And with greater coffee comes greater sloshing. So I would suggest that if you actually have a very, very big cup of coffee, you hold it with 2 hands, but if it's still big enough for you to use the claw hand grip, just go with it. Trust science.
The Fluid Dynamics Prize winner. That was great. Thank you. The Ig Nobel Nutrition Prize was awarded to a team from Brazil, Canada, and Spain. Fernanda Ito, Enrico Bernard, and Rodrigo Torres were honored for their production of the first scientific report of human blood in the diet of the hairy-legged vampire bat. They also were not able to join us, but they prepared a short video acceptance speech, which we showed at the ceremony the other night and which we will see again now.
We have to make a speech to
Can we have the lights down?
outstanding prize. Fernanda, do you accept the prize? Mm-hmm. Rodrigo, do you accept the prize? Mm-hmm. We do accept the prize.
Okay. The Medicine Prize. Also, the team that did the Medicine Prize was not able to travel, so they have a video which we'll be showing in just a moment. I'll read you the citation first. The Ig Nobel Prize for Medicine, the team is from France and the UK. They were honored, well, their names are Jean-Pierre Royer, David Mounier, Nicolas Torquay, Anne-Marie Mouly, and Tao Jiang. They were honored for using advanced brain scanning technology to measure the extent to which some people are disgusted by cheese. I'm almost certain that a number of people in this room use MRI machines in your research, so you have some idea of what it was like physically for the people who were being measured. This is how they were being measured in these machines. Here is the acceptance speech from France.
In France, we have 1,600 varieties of cheese, but we have shown that 6% of people were disgusted by cheese, a higher number than that found for other foods. In addition, from 1 to 6 members of their family also dislike cheese. The disgust is not only observed in France, but probably in most countries in Europe and in USA. Using a fMRI scanner, we observed that a small brain area activated when we are hungry and stimulated by food odors and images was deactivated in subjects disgusted by cheese. By contrast, 2 other areas involved in aversive behaviors were more activated in these subjects than in subjects like in cheese. In cheese lovers as me, it's a real delight, mainly with a good wine. But you must come to force to experience this. Cheers.
The Ig Nobel Cognition Prize went to a team from Italy, Spain, and the UK. Matteo Martini, Ilaria Bufalari, Maria Antoinetta Stasi, and Salvatore Maria Agliotti won their prize for demonstrating that many identical twins cannot tell themselves apart visually. Please welcome the team that did this work. Do we have any twins, identical twins here? Would you? Wow!
Can they tell each other apart? Boy, have we got a device for you later.
Okay, so congrats, by the way. Sorry, I'm still panting because I was in the toilet. Anyway, hello everyone. Hi, Katz. Thanks, Mark, for the invitation. So this is an article that has been published just a few days ago in the MIT Technology Review, and it basically says that facial recognition technology is being so good nowadays. It's getting better and better. So good that we can now catch trains and make payments, and we can even now tell apart the sexual orientation of people just by using pictures. You can unlock your iPhone 10 and we can identify the identity of one face even if that face is covered or is disguised. And this is really exciting because it means it means that we're finally close in knowing who is the man behind this costume. But apart from technology, are humans good at telling faces apart and at recognizing faces? Well, it depends on many factors. For instance, it depends. This depends. It depends on which faces, obviously. But one factor is the facial orientation. So we know that if a face is displayed upright, we're better compared to a face that is displayed upside down, and the so-called face inversion effect. We're also better at recognizing our own race respect to other race faces, and well, we're better at surprisingly recognizing very familiar faces compared to stranger faces. But above all, the so-called self-face advantage, we're better in recognizing our own face over other, even very familiar faces. And why is that? Well, because our face is very, very salient for us. It means a lot, and is strictly related to the self-identities, also to the concept of identity and the bodily self. But for some of us, this concept of identity may have the boundaries a bit blurrier. So this has been suggested is something that happens in monozygotic twins, in identical twins. And so here comes our study. We wanted to see whether, despite having basically a clone of yourself, you still have this self-face advantage.
The experiment took part in 2 days. On the first day, the trios of twins, oops, it disappeared.
The special effects.
My goodness, that's Vegemite.
Oh. What happened?
Oh.
This isn't counting against your time, by the way.
Yeah. I'm not sure. There we go. That's okay.
So we have trios of twins I will not touch this anymore. So we have trios of twins and friends. And on the first day, we asked them to come to the lab just to take pictures, even though it seems that we put them under arrest here. It's not. It was just a picture. Then between the first and the second day, we prepared the visual stimuli for each trio. So they consisted of their faces, the faces of the two twins, and of their friend, which were presented in upright or inverted orientation. And also we removed all the external facial features such that face recognition could rely only on the internal facial features. And this is a typical trial. There was first a fixation cross, which signaled that a face was going to appear, and the face was presented very briefly, just for 30 milliseconds. And we made this on purpose. We made the task difficult such that we could uncover subtle differences between the faces of the twins. And then they had to respond which face they had seen, which of the three faces they had seen. These are the results. On the y-axis, we have a face recognition index. The higher the value, the better the performance. And in the upper left part, we have the performance of the friends. And as you can see, they are better. Okay.
Round of applause.
We want to acknowledge.
Okay. So twins do not tell themselves apart, but we have some suggestion for her. And okay, we wish to thank them.
Okay, nice. Well, if you have a question, raise your arm and wave it so we can spot you.
Thanks so much for your presentation. I was wondering, since you mentioned that self-recognition has a lot to do with self-identity, if twins have less self-identity than the average person.
Yeah, well, this is something that has been hinted at in previous literature, yes. The facial recognition is something that can index somehow this, the levels of, identity, if you wish. But, yeah, it's something that is difficult to actually measure unless you ask them, but I'm not aware of any questionnaires.
They rely on different processes. Since they have this shared bodily identity, probably it's more difficult to differentiate, even in their personality, for example, no? So the best way, I think, a suggestion for her also is to try to dress them in a different way, to make them go to different schools, so to differentiate them the most.
Thank you.
Yeah.
Because they can have difficulties in
telling themselves apart, yeah.
Hi, thanks for the presentation. Is a problem that we don't really know how we look. Our common image of ourselves is the mirror image rather than the photographic image.
Yeah.
Yeah, and actually we use the mirror images just because, as you pointed out, we're very familiar to mirror images rather than picture images. So that is something that we took into account in the study. So the right part was on the right, and the left
like in the mirror.
Like in the mirror, yeah.
Okay. And question right here. If you wait till the microphone reaches you.
A quick counterpoint. A lot of people take selfies nowadays.
Like I said, a lot of people take selfies, pictures of themselves.
Yeah.
So what is your question? Have you had trouble recognizing yourself?
Yes, that's true.
Your selfies?
Selfies revert images for you.
Okay.
Taking a selfie is not a mirror image, it's a photographic image.
Okay.
Okay. Does that answer the the question more or less? that you-
Although by the time we ran this study, we collected the data, selfies, yeah, were not so famous. Not
Yeah,
yet.
at that time.
At that time.
Okay, thank you very much. We have only 2 talks left. One of them is from the Obstetrics Prize winner this year, and then we will hear from Thomas Thwaites, whom you know as Goat Man. The Ig Nobel Obstetrics Prize this year was awarded to the team who came from Spain, kindly to join us, Marisa Lopez Tejon, Alex Garcia Faura, Alberto Prats Galino, and Luis Palares Aniorte, for showing that a developing human fetus responds more strongly to music that's played electromechanically inside the mother's vagina than to music that is played electromechanically on the mother's belly. Please welcome the team that did this research. Yeah. Okay. No, I'll get it. No, it might be easier if I do. Oh, okay.
This is what we have discovered. When the fetuses listen to music, they react with mouth and tongue movements. They try to vocalize, but the only way the sound can reach them is through the vagina. Student Marquez is carrying out state-of-the-art research on how music impacts the embryonic and fetal development. We have improved in vitro fertilization by applying musical vibrations inside the embryo incubators. Hence, the next step should be playing music to the fetuses. We saw that the speakers on pregnant women's bellies, even with very high intensity, didn't induce any fetal reaction, so we thought perhaps they weren't able to hear the sound. Therefore, we had to bring the sound closer. We had to introduce a speaker in the vagina of pregnant women. Obviously, I only got people to laugh at me. But Luis Pallares designed exactly what we needed.
Wow. So this is the baby pod. This is an intravaginal speaker that connects to an external source of sound. All right. Oh, you moving it? All right. So when the sound is playing from the outside of the womb, the fetus only receives distorted and absorbed sounds. And that is due to the layers of soft tissues that make up the abdominal wall, as you can see on the left side. Right. So as you all know, the vagina is a closed space, and therefore there's no sound dispersion on it. With the baby pod, the layers that separate the fetus from the sound emitting device are way less. It's only the vaginal wall and the uterus. So we are able to get rid of the abdominal wall.
So we perform a clinical trial with more than 100 patients to compare fetal facial response with 3 different stimuli: abdominal music with standard headphones at the belly at 98 decibels, which would correspond to intensity of a train passing by at a short distance, The second group with intravaginal vibration, and yes, we used a sexual toy, no problem, with our patients who were happy with that, at 68 decibels, which corresponds of the intensity of a loud discussion, so it was quite high. And finally, with the baby part, intravaginal music at 54 decibels, which is the intensity of a normal conversation. The results with the first two groups, there was no changes on fetal facial expression, and only when we played intravaginal music, the fetus started to wake up with unspecific limb and head movements, and especially with specific mouth movements, with wide mouth opening and complete tongue protrusion, which is very unusual. So we published our conclusions in the ultrasound, and concluded that when we play intravaginal music, we will induce a specific fetal response with speech movements, that this response is due to audition and not to vibration, because there was no response when we played vibration at a high intensity, and that the only way to stimulate fetal audition is through the mother's vagina, because there was no fetal response when we played music through the abdomen. Other interesting clinical findings was that fetal audition starts at the 16th week, when it only measures 4 inches, and which is 11 centimeters, much earlier than it was published before. And our theory, our hypothesis from a neurological point of view, is that music is able to stimulate brain pathways related to language and communication, and that are located at the primitive brainstem. We also studied fetal response to different types of musics and human voice, and there are very interesting differences between voices and musics. And now that we know that we can communicate with the fetus and that we can stimulate its brain before birth, we've studied many RDI projects related to fetal brain imaging with MRI and postnatal follow-up of these babies, just to see if we can improve learning, communication, and maybe learning could start into the womb.
Meow,
If you have a question, wave your arm vigorously.
If you want a demonstration, I think we had a pregnant patient in the audience. No?
I think you might want to get permission from the mother first,
probably.
yes.
And from the MIT?
No, MIT's good about things like that. There.
So you said that this research has shown that we can communicate with fetuses, but have you really found that fetuses have anything interesting to say?
Well, it's quite difficult to introduce, it's quite easy to send sounds, but it's quite difficult for the fetus to talk when the lungs are completely collapsed.
Yeah. Okay. The woman in blue right here.
The fetus facial expressions change depending on the kind of music to indicate whether they liked something or didn't like something, like, turn this stuff off, or, ooh, this is really cool.
Well, of course, that's the slide that I showed you. That's only a small, we've tried it in more than 1,000 patients with 20 or 30 patients per group. You can see, especially, they like Mozart. I think we already know with babies. Also, Bohemian Rhapsody, that I don't know if it's on the slide, it's fantastic and they love it. And also ancestral music that have gone from one generation to another one. We get almost 90 or 95% fetal response. And when they stop, it looks like if they wanted to sing or talk, and they don't stop talking for the whole ultrasound. It's very, very nice to see it.
I noticed you didn't use Barry Manilow.
That we used?
Barry Manilow.
Yeah, well, that's because we thought when we looked at human voice, we saw that fetus would start opening the mouth, but they won't protrude their tongue. And we were very surprised. And we thought, well, why? Well, that's because when you talk to a baby, we usually don't use our normal voice. We use a high pitch. Say, hello, baby, how are you? No? And the fetus then will listen to you and won't start crying. That's why we tried Mickey Mouse voice, and we were right, because with Mickey Mouse, we started to have also tongue protrusion that we had never had with other types of human voice. And there's no difference between the mother, father, or any other person's voice, because they have never heard the mother's or father's voice, because it's coming from the outside.
If you had Russian Led Zeppelin, you might get an interesting response, too.
Okay. And another woman in blue over here. You? Wait till the microphone reaches you, please.
I think another experiment you could try is to insert a didgeridoo and see how the baby responds to that.
Well, wait. When you said another experiment you could try.
I will tell you, I have inserted something still longer than that. With functional MRI, with brain imaging for the fetus, we couldn't introduce metallic parts into the MRI. So we designed well, I don't know in feet, but in meters it's 17 meters. It's like a trailer, large tube or penis that had to go into the vagina from the control room to the, well, from the roof of the Faraday room. And we've already started clinical trials to see brain mapping activation, and it was the only way to do that. So I promise it was longer than dildo.
Yeah, that is an experiment that you can try.
We count on you.
Okay. All right, one final question. Why don't you choose which person?
Maybe him, on top.
Have you considered communicating with the embryos using stem cell phones?
Wait. No, we don't want that. All right, we will take one more from our Ig Nobel winner in the front. If you wait till the microphone comes down here, or come up. Yeah.
Very exciting. I have a question. Are you all interested to have a feeling how a fetus feels when sound is out of the belly or in? I will do that so. You can close your eyes, and I will play outside of the belly. This will be the belly here, okay? The whole room, okay? Close your eyes.
All right, but if you want to have your eyes open, we can have a sort of visual demonstration. Gary Dreyfus, are you still here? Oh, you're not here, okay.
On the belly, just put it on the belly.
Yeah, just stand as if you were the target for this. It's purely visual, that's all.
We're on the belly, yeah?
Yeah.
First sound from outside of the belly, yeah?
Who's the fetus?
Eyes closed.
Yeah, that's right.
Thank you very much. If you have any further questions, they'll be around for a while. And it was not planned that there would be babies here present. It's just a happy coincidence. So thank you very much.
Mark. Thank you.
Thank you. Okay, our final speaker, we're very pleased, could join us. Last year he won his prize, but he was not able to come and take part in the lectures here at MIT. So we're really thrilled that he is able to join us today. Last year, he was living in his native England. He has since moved here. He's now a professor in Providence at the Rhode Island School of Design. The GOAT project is not his first big project, but there's only time to to mostly talk about that today, and that only briefly. Well, I'll read you the citation from last year. The Ig Nobel Biology Prize in 2016, last year, was awarded jointly to 2 people. This is one of them. They worked completely independently doing different things. The prize was awarded to Charles Foster, who you did see here if you came to the lectures last year. It was awarded to Charles Foster for living in the wild as, at different times, a badger, an otter, a deer, a fox, and a bird. That's what Charles Foster did to win his prize. And it was awarded jointly to him and to Thomas Thwaites, who created prosthetic extensions of his limbs that allowed him to move in the manner of and spend time roaming hills in the company of goats. Please welcome Thomas Thwaites. Here we go.
And then I filled out a funding application, and they gave me some money to do it. Yeah, I'm a bit worried about how many slides I've got. So the question was, what animal do I want to try and become? And my first thought was... Could you speak into the microphone? Oh, yeah. My first thought was elephant, because, like, it looks quite fun, you know, they look like they have a nice time. However, I did a little bit of research and discovered that elephants, they're one of the only other species that seem to kind of mourn their dead, perhaps, and they exhibit kind of symptoms of post-traumatic stress, and they live in kind of these complex social groups. And that all sounded pretty stressful. So I wanted to get away from that. So I was moaning in the pub to a friend who was like, oh, you know, I've got some money to become an elephant. I don't want to be an elephant anymore. What should I do? And she said, well, go and visit an expert. So I went to visit a shaman in Denmark, and she told me I was an idiot for even thinking I could become an elephant. Of course, I should become a goat. And so how do you... the other thing she pointed out was it's not a new idea to want to become an animal. People have been wanting to become animals possibly since the beginning of humanity itself. This is the oldest piece of figurative art ever discovered, carved 40,000 years ago from mammoth ivory. And fast forward to the present day. So what can present-day science and technology say about this ancient human dream? Okay, I want a mind of a goat. So as we are discovering that there's an expert in everything. So this is a expert in goat psychology. He took me to visit his research subjects at a goat sanctuary, and he said, you need to switch off your ability to speak and your ability to imagine the past and imagine the future. Remember the past and imagine the future. So I went to see a neuroscientist, Dr. Joe Devlin, and asked if he could switch off those parts of my brain.
So that's the hard coil. So this is the T-Mesh coil. It's on and it's set so that it'll do stimulation. If I step on this, you can hear it. It makes a clicking noise. Yeah. Basically, because the magnetic field sort of comes on and off so quickly that it actually creates what are called the Lorentz forces that make physical sound.
So it should be, who's that trapping over my bridge? So he's using TMS to try and target a part of my brain called Broca's area, which is used in speech. He kind of got it. The next day, a metal filling in my teeth fell out. So, body, I thought this would be easy because, you know, we share so many bits of, you know, goats that surely it should be easy.
You've only got 2 minutes left.
I better accelerate. Yeah. So this is my first attempt. God, in the hallowed halls of MIT. This is my second attempt. Not quite the kind of bounding across the landscape that I was kind of hoping.
Are you trying to carry coffee
So I went to visit an expert and pointed out that we share all these same parts. He pointed out we share same parts with all animals. And he took me on a little tour of his work, and he was dissecting a snow leopard. I said, how many goats have you dissected? He said, none. I said, if I could get you a dead goat, could we dissect one? So I went back to the goat sanctuary, and unfortunately, this is Venus. She was dying, and she did die on a Sunday. She had to spend the night in my fridge at home, and then I took her to the Royal Veterinary College. Cover your eyes if you're afraid of meat. And so we dissected Venus. It was a very interesting kind of investigation into the differences between engineering and sort of biology. This is Venus's brain. And yeah, so I realized I'm trying to make prosthetics, of course. And so I went and had some prosthetics made at a prosthetics clinic. And then I also realized I needed to be able to not just eat grass, but of course digest grass, because we can eat as much grass as we want, but we can't digest it, so we can't survive, and so we can't be free. We need money. So I decided I needed to make an artificial one of these, a rumen, and I went and found some artificial rumens, and then I went to Switzerland, and then I found myself amongst a herd of excited goats, and then off we went, and then, okay.
I cannot bear to stop this.
We could do questions. This could be questions.
Yeah, while this is going on, if you have a question, just raise your hoof and wave it.
What about cats?
Microphone.
So the practical implications for this are...
Wait. Could you clarify that question? Practical for the human or for the goat?
I'm going to spin it out as a kind of holiday company. Yeah.
Okay. Next question. Wait till the microphone right next to you.
Yeah.
Yeah, but
Why?
The why. Well, that's a good question. I don't know. It was a dream. The pursuit of dream. Yeah. Why go to the moon?
Because this is the final speaker and because he was a goat, we'll take some extra questions. Your choice, Thomas.
So in your interactions with the goats, did you draw a line somewhere, or was everything fair game?
Yes. That question did arise early in the research as a kind of ethical consideration. And my solution was to make sure that I went to commune with the goats outside of the rutting season.
No. if I may step in for just a moment. Earlier this year, we were both part of an event at Imperial College in London. And Thomas was talking in a little more detail because we had more time about his relationships, if any, developed. And I remember you mentioning that there was one goat in particular.
Yeah, there was.
I remember the phrase, I think, goat number 18.
Yeah.
Could you tell us a little about goat number 18?
Yeah, so I was with these goats for 3 days, and over the course of that time, I think I developed a rapport with a particular goat. I would just be doing my thing and then turn round and there was goat number 18 and I could, just wander off after her. And, the thing is was it a platonic relationship in her eyes? And I don't know. I don't know if we'll ever be able to answer that question truly. But I think it was. It certainly was physically. But goats are social animals. They live in social groups. They have their their enemies, but they also have their allies. And so I was definitely a goat at the very bottom of the pecking order. So maybe she was as well, and we were, teaming up. Yeah. Heartening. Yeah.
Let's move on to the next question. Do you choose?
In the aisle.
While you were a goat, did anyone try to drag you? And from the perspective of the draggy, maybe you could give us some insight into that sort of thing, like.
That could have been. I mean, that's opportunities for collaboration. There was a question, the goat farmer, when I turned up and said I want, I hadn't told him that I wanted to, I just said I was interested in goats, so I turned up and said, actually, I want to become one of your goats. And he was fine with it, and he said, the question of milking arose, and so not shearing. I guess you don't really shear goats, do you? So no, I was never dragged.
This was on a mountain in Switzerland, correct?
Yeah.
Switzerland now is becoming famous for the sound of didgeridoos being played. Did you hear while you were a goat any?
The goat herd, he played a Swiss horn. It was amazing. Yeah, it kind of echoed around the hills. Yeah, a bit like that. Yeah.
Okay. One final question from the woman in red, right here. The microphone is on its way.
Planning on visiting Goat 18 again?
Well, no.
She probably misses you.
God, I hope Goat 18 is still with us. She might be dead by now. But maybe I should find out. But no. It was kind of painful and smelly, and I was like, it reminded me how wonderful it is to be a human being. Yeah.
Before Thomas sits down, before we finish, I want to mention he used to be quite well known for a different project before the goat thing came up. And I wonder if you could take just a couple seconds to tell us about the toaster project. It's a very MIT flavorish.
Yeah, so yes, I once spent kind of about 9 months deciding that I was going to try and make just one simple object entirely myself from scratch, and I chose a toaster because I was inspired by the 5th book in the Hitchhiker's Guide to the Galaxy trilogy by Douglas Adams, and there is a passage in that where the hero realizes that he can't do anything if he's left to his own devices. He can't even barely make a sandwich, let alone a toaster. So I tried to make an electric toaster entirely from scratch, like mining the raw materials and so on, and kind of 9 months later, I guess like weirdly similar results of this kind of goat experiment. Yeah. So yeah, a very expensive, weird-looking, non-working toaster. Yeah.
Thomas
Okay.
Thwaites. Well, I'd like to ask all of our cat timers to take a bow, and if you could thank them. And I'd like to ask all of our speakers to come up front with the cats and turn around for our traditional pointless photo opportunity. Please, please. All right. Please, a hand for the Ig Nobel Prize winners. Thank you to the MIT Press Bookstore for organizing this. There are lots of books out there. Thank you all for coming. You can see video of the whole Ig Nobel ceremony up on our website on Improbable Research, improbable.com. So see you next year. Thanks. Wonderful.